Jai Hind. The topic for today's lecture is basically we have already discussed ER diagrams. Today I am going to cover certain case studies so that this concept become more clear to you. And this particular topic, it comes under category of under unit 1 of the subject DBMS. These things we have already seen. Let's go through once again. It's a kind of a revision. So basically, what are the characteristics of ER model? All these things I have already discussed in my previous lectures. Basically, it is a semantic data model. It expresses the logical properties of an enterprise database. That is, all the relations, entities, attributes, everything is going to be captured in this figure. And it is a design tool and documentation for the database structure. It serves as a design tool for the database designers. For this, no physical DBMS is required. Basically, it is proposed by Dr. Peter Chen, and this concept is more in detail provided in UML, that is Unified Modeling Language. It is a unified modeling language basically. So when we talk about the components of ER model, this we have already seen. When we say components of the ER model, we are having entity, we are having attributes, keys, relationships, and the constraints which we decide on the relations. So basically, entity, we have already seen that it is an object or concept, and under this we have already seen we are having two types of entity. One is a strong and another one is my weak entity. Weak entity, it is also known as child or dependent entity, that is whose existence is solely dependent on other entity. Then we say it is a weak entity. For example, if I'm talking about a database of an organization, here I am keeping the details of the employee. This is the one entity, and I am also keeping keeping the details of the child, or you can say dependents of this particular employee. So if I say this is weak entity for that particular organization, because for its existence we require this entity, that is the employee entity. So this is weak entity and this is my strong entity. And the diagram notation is basically, in most of the UMLs you will find rectangular symbol. Attribute, basically these are the properties which we assign to an entity. For example, in this case, if you see, this is entity and these are my attributes. Attributes are generally represented by the oval sign, and its types are single attribute. For example, if I say I am having student ID, this is my single attribute. Composite attribute, if this attribute is comprised of multiple entries. For example, if I say student name, then in this case it is my composite attribute. Then I am having single valued, which is having only single value. I am having multi-valued attribute. For example, I am having this is having multiple values. Student phone numbers, mobile numbers, they could be many mobile numbers corresponding to a single student. Then I am having derived entity, that is, in this case it is my age, and we have already seen that for the derived entity we use the dotted oval shape. For the multi-valued entity, for the multi-valued attribute, we use this particular symbol. And if one of the attribute is my primary key or any key, then we represent it with the help of underline symbol. Another important component in the ERD we have already seen, that is the relationship. So it is nothing when two entities, they share the common you could say relation, then we say there is a relationship, and it is generally represented with the help of a line, and on the top of the line we could write the role name or the relation name. Here we are having degree of relationship. We have already seen when we say the degree of relationship, basically number of participating entities. So in this case, how many entities are participating in the relation 2? So this is the example of my binary relationship. We are having unary, binary, ternary and quaternary relationship. In the unary relationship, what is happening? Only one entity is involved, that is itself. That is why it is also known as recursive relationship, something like this. Binary relationship we have already seen. If I having another entity, then in this case it is my ternary relationship, and if I am having one more, then this is my quaternary relationship. So we have seen the degree, that is binary connects two entities, unary one entity, and complex, that is three or more. And it is my degree. Another important term is multiplicity. When we talk about the multiplicity, here we are having two things. One is cardinality and another one is my participation. What is cardinality? That is my both the things, they are my relationship constraint, and in this case I am having three basic types of cardinality, that is one to one, one to many and many to many. That is how many elements or instances of one entity is related to other entity, that is my cardinality. For example, if I say one to one, then this is my one to one cardinality. When I am saying one to many, then in this case it is something like this. And when I am having many to one, many to n, then I am having this kind of cardinality. Another important relationship constraint is my participation, that is full or partial. In the case of the full participation, it is always mandatory, and whereas in the case of the partial participation, it is optional. So here it is an example of you could say one to one, one to many and many to many relationship. So every person has only one passport. A customer can place multiple orders, and a student can be assigned to us multiple projects, and a single project it could have multiple students. We have already seen degree. So in the case of the binary, we are having two entities. This is my binary relationship. This is an example. That is, we are having the recursive unary example. We are having a staff, and in the staff we are having a relationship of supervisor and supervisee. So employee, it can be a supervisor, and it can be the same person could be a supervisee, and he's a staff. So this is an example of the unary relationship. Complex, this is an example of my complex or the ternary relationships. Multiplicity, which we have seen when we say how we show the relationship things. In many diagrams you will find this particular kind of thing. So here this is my you could say participation. The first symbol, it represents the participation, and the second it represent, and this represent my cardinality. So here what I am having, entity has entity 1 has 1 to m relationship with entity 2. That is, this entity is this with this 1 to m. And participation in this case, for the entity 1 it is 1, that is it is mandatory, whereas participation for entity 2 is mandatory, whereas for the entity 1 it is optional. So we are 0 or 1 for the optional, then 0 or more, again it is optional, 1 between 1 and 4, between 1 or more, it is mandatory. This is a simple example. Here I am having manager, and he manages a department, and there is another you could say relationship that is a responsible for which department. So if I say here each manager manages up to 3 departments, we have shown it with because here we are having 1 to 3 relationship, but need not manage any department. Here it says each department is managed by 1 manager, and these are my your relation. It can also have the attributes. So what are the basic steps to create an ER diagram, first we identify what the things we are identify all the you could say your entities, your relations, your attributes, keys, your cardinality, your participation constraints, each and everything first you need to identify when you are having some problem in your hand, and after that you start creating the ER diagram. The very first case study in this, what we are having a music database which is designed to store the details of a music collection, including the albums in the collection, the artist who made them, the tracks on the albums, that is, we are having artist, we are having tracks, and when each track was last played. All these details we are going to maintain in that particular ER diagram. We want to represent in an ER diagram. So first we will draw up the clear list of requirements. What are the clear lists? The collection, it consists of the albums. An album is made by exactly one artist. Now this thing is already been decided, how that one album is only by one artist. This is the restriction we have put over there. An artist makes one or more albums. An album contains one or more tracks. That is, an album, it could have multiple tracks. Artist, album and tracks each have a name. So they are acting as an entity in this case. Each track is on exactly one album. That is, every album is having a track. Each track has a time length measured in, that is, it is, you could say it is a attribute of a track, that is a time length. When a track is played, the date and time the playback began to the nearest second should be recorded. That is, at what time the track started playing. This is used for reporting when a track was last played, as well as the number of times music by an artist from an album or a track has been played. Another requirement provided in this particular case study is there is no requirement to capture the composers, group members or the sidemen. That is, we are having only artist, album and track. Recording date or location, where we are location, what are the source media or any other details of artist, albums or tracks. So we need to capture only this information in our ER diagram. So what are the major findings? It consists of only one-to-many relationship. And what are those? One artist can make many albums. One album can contain many tracks. One track can be played many times. So this is one-to-many relationship in this case. Conversely, each play is associated with one track. So a track is on one album and an album is by only one artist. The attributes are straightforward. Artist, album and tracks, they have names as well as identifiers to uniquely identify each entity. So these are my three entities. They are having names. They are having the identifiers. The track entity has the another, this we have already seen, that is the track entity. It is having this attribute is already provided. So the track entity has a time attribute to store duration, and the played entity, there is another entity which that is the played, how many times the particular track has been played, has a time stamp to store when the track was played. The only strong entity in the database is artist. This is important point to be noted down. Because we have identified the attributes, we have identified entities. Now, which we need to identify the strong entity and the weak entity. So in this case, artist is the strong entity, which has artist ID attribute that uniquely identified. Each album entity is uniquely identified by its album ID combined with the artist ID. as we have already seen in the previous lectures, that when you need to identify a particular instance from the weak entity, then you need to combine its identifier with the identifier of the strong entity. So in this case, we are aware that album entity, it only exists if there is an artist. If there is no artist, then the album entity won't exist. So in this case, we are having to uniquely identify an instance from the album entity. We need the album ID as well as the artist ID of the corresponding artist entity. A track entity is similarly uniquely identified by its track ID as well as by the album ID and the artist ID attributes, because the track entity, it depends not only on the artist but as well as on the album ID. The played entity is uniquely identified by combination of its played time and the related track ID, album ID and the artist ID attributes. So we have identified all the things in our problem statement. So when we draw the ER diagram, so we are having an artist and album, the relationship is compiles, and we have already seen that an artist, it can compile many albums, but vice versa, that is each album is having only one artist. So this is the cardinality over here. Artist, we have identified two attributes. Album again two attributes. Track is having three attributes: track ID, track name as well as time. So what is the relationship between album and track? Each album contains the track and each album could have multiple track, but a track, it is only on single album. So this is my relationship. Track was played at, this is another entity played, and it is having only one attribute, that is played, how many times it has been played. So this is the ER diagram for this particular case study. Next important case study is your university database store, which details about the university, students, course and semester. A student took a particular course and his marks and grades if he completed it, and what degree program each student is enrolled in. So what are the requirements provided in this case study? The university offers one or more programs. A program is made up of one or more courses. A student must enroll in a program, and a student takes the course that are part of her program. Each program has a name, a program identifier. These are the attributes of a program entity: name, program identifier, total credit points required to graduate, and the year it commenced. A course, this entity has attributes: name, course identifier, credit point value and the year. Students have one or more given names: a surname, a student identifier, date of birth, year they first enrolled. We can treat all the given names as a single object. For example, John Paul, that is name a single entity. When a student takes a course, the year and semester he attempted it are recorded. When he finishes the course, a grade and a marks are recorded. Each course in a program is sequenced into a year. For example, first year or first semester, first year, second semester, like this. So what are the major findings which we can gather from this particular case study? Student, it is a strong entity in this case. With an identifier, these are the attributes: identifiers, student ID created to the primary key to be distinguished between students. Program, it is again a strong entity with a PI, program ID, as a primary key. Each student must be enrolled in a program, so the student entity participates totally. Participation is total participation, many to one, and the relationship in this case, for example, enrolls in relationship with the program. A program can exist without having any enrolled students, so it participates partially in this relationship. A course has meaning only in the context of a program, so it is a weak entity with course ID as a weak key. This means course is uniquely identified with the help of course ID and program ID. Another, as a weak entity, course participates totally in many-to-one identifying relationship with its owning program. This relationship has year, semester attributes and identified sequence position. Student and course, they are related through the many-to-many attempts relationship. Because if a student fail, then he might go for another attempt. A course can exist without a student. That is, maybe a student doesn't enroll, for example, your elective courses. In that case, there are certain electives in which no student enroll. And a student can be enrolled without attempting any course, so the participation is not total in this case. When a student attempts a course, there are attributes to capture year and semester and the marks and grade. So, let's see the ER diagram now. So here we are having the entity, student, program, course. These are the three entities which we have identified. These are the attributes of the student. These are the attributes of my program for my course. Now look at the relationships. A student enrolls in a program, and in this case a program can have multiple student. In this case, a program, it contains multiple courses, and this contains this relationship. It is having year and two attributes, that is year attribute and the semester attribute. Here we are having course as a weak entity, so the relationship is my weak relationship in this case. Now the course, in this case the student, it attempts a single course. In this case, the student can make multiple attempts to a single course, and a single course, it could have multiple students. So again, your attempt relationship is having these four attributes, that is in which year, what is a semester, how many marks the student get, what is the grade. And here the relationship is many to many, cardinality, that is your degree, sorry. And this is my binary relationship. Again, this is my binary relationship. So this is the ER diagram for this case study. Another case study which I going to discuss is a big company has decided to store information about its projects and employees. The company has wisely chosen to hire you as a database designer. So now you need to prepare a ER diagram for this company. What are the description? That is, what is the requirement? The company has a number of employees. Okay, so this is entity. These are my attributes. The company has a set of department, another entity, and each department, this is the attribute. Employee work in several projects. Each project, that is again the work for project again become an entity, has P name, P number as an identifier, location and city. Each employee may have a set of dependent. This is another entity, and this dependent has these attributes. Note, if the employee left the company, no needs to store his dependent info. So what it imply, that this is going to be my weak entity. With the help of this particular statement, we identify. For each department, there is always one employee assigned to manage that department, and each manager has a hiring date. The department may have employees, but employee must work on only one department. That is, a department has many employees, but one employee corresponds to one department. Each department may have a set of projects, multiple projects, and each project must be assigned to one department. That is, each project is to be handled by a single department. Employees work in several projects, and each project has several employees, and each employee has a number of working hours in each project, and each employee has a supervisor. So when we compile this information, so what first thing comes, the entities we have identified: department, employee, project and dependent. These are the four entities we have recognized over there. We have identified these are the attributes, locations. This is my multi-valued. This is my key in this case, and employee. These are the attributes. Name, it is again further divided into F name and L name. Composite attribute is here. It represents the composite attribute. In the case of the dependent, we are having name, gender, and birth date. In the case of my project, these are my attributes. Now come on the relationship part. Department and employee. Between department and employee, we are having the relationship assign, as well as the manage. That is your manager. Again, each employee is having a supervisor. So this is the relationship. That is, in this case, this is my unary relationship. This is my binary relationship. Again, this is the binary relationship. Each employee works on a project. So this is the work relationship. Each employee, we are maintaining the dependents of employees. So they are the has. Each employee has the multiple dependents. So we are having 1 to M relationship in this case. In this, the employees, they can work on multiple projects, and a single project, it could have multiple employees. So we are having M to N relationship. In this case, each employee is supervised by only a single supervisor, and a single supervisor, it can supervise multiple employees. So we are having N to 1 relationship. In this case, each department is to be managed by a manager. So we are having employee to a single employee, it can manage multiple departments. So we are having M to 1 relationship. And if we see here, this relationship is having its attribute, hiring date, as well as in the case of the work, we are having number of working hours. So this is and each department has got multiple projects. So this is another relationship. So this is the ER diagram for case study 3. So these are the 3 case studies, and all these 3 case studies, they are quite diverse in their nature, their behavior. So I took these case studies to make you aware the concept of ER diagram into more detail. So these are the references which I used to for preparing my slides. Thank you and Jai Hind.